to answer our question that has been presented to us. So before we answer, we want to make sure that we understand everything that is mentioned in the question. So this is coming from 2024 internal. It's saying the figure below shows a circuit with resistors connected in parallel. So you can see that we have cells here. When they are put together, we're calling them a battery. So there is 10 volts, and we have this resistor and this resistor. So the way they are arranged, we are saying they are connected in parallel. So this one has 3 ohms and this one has 6 ohms. So the first question they want us to answer is, what is the effective resistance? The second question they want us to answer is, calculate total current. And the last question is saying, calculate the charge in 1 minute. So we are going to try and answer these questions. Hope you get the concept. Okay, so the first question says that what is the effective resistor? What is the effective resistance? So the formula for resistance in a parallel circuit is RT is equals to R1 multiplied by R2 divided by R1 plus R2. That is our formula. That is our formula for total resistance in parallel. So this RT, it means total resistance is equal to resistor 1 times resistor 2 over resistor 1 plus resistor 2. So we answer our question. So to answer our question, we are going to say total resistance is equal to, so the resistance that we had 3 ohms and 6 ohms. So we're going to put this one can be our R1 and this one can be our R2. So we're going to say that R1 is 3 times R2 is what? Is 6 over R1 again is 3 plus R2 is what? Is 6. Then now you're going to say total resistance is equals to 3 times 6. It will give us what? 18. We can confirm that by using a calculator. So this is science. You can use a calculator. So we're going to say 3 multiplied by 6 gives us 18. And we're going to divide by 3 plus 6. You can punch on the calculator to give us 9. So then you continue by saying total resistance is equals to 9 into 18, it will give us 2. Then remember, we are looking for resistance. So resistance has units which are ohms. You're going to put the symbol like this. Means you have answered, you have found the total resistance. You have found the total what? The total resistance. Okay, so we can move on to the second question. We're just going to put our total resistance on the corner there, since we are going to rub this side. So our total resistance has been 2 ohms. Hope you have hope it was clear. Okay, can go on to the second question, which is calculate the total current. Calculate the total current. So this question can be asked in 2 ways. Sometimes they can say calculate the current passing through the battery, and sometimes they can say calculate the total current. So it only means one and the same thing. So to calculate the total current, we use the Ohm's law formula, which we said is V. It is going to be V is equals to IR. V is equals to IR. So since they have said calculate total current, you're going to say data. So to calculate total current, we need voltage and resistance. It means when you have voltage and resistance, we're going to have current. So voltage, resistance, and current. So current is the one we are looking for. So we're going to say question mark. Then since they have said calculate total current, everything, all the data that we have should be total. So what is our total voltage? So our total voltage, remember from the batch we had the 10 volts. Then our total resistance is the one that we answered in our first question, which is 2 ohms, was 2 ohms like that. So provided the data we have, we can answer the question. So we are going to say V. What is on V? On V we have 10. 10 is equals to, what is I? I, it is the one we are looking for. We are going to put I. Then multiplied by R, it is 2. Then we continue by saying I times 2, it is going to give us 2I. In this side we drop the 10. What's next? We are looking for I, meaning we divide both sides by what? By 2. So this one and this one goes. We remain with what? I is equals to 5. Then remember, current is measured in amps. So we're going to put our capital letter A there. It means we have answered our question. So okay, like that. So we have tackled 2 questions. So we are going to put our total current here, the one that we answered, to be 5 amps. Then hope that was okay. We are together. Can continue by answering our last question, which was saying calculate the charge in 1 minute. Calculate the charge in 1 minute. So charge, the formula is charge is equals to current multiplied by time. That is the formula for charge. So the capital letter Q we see right here, it means charge, then I, current, multiplied by time. So first thing we want to look at the SI units for charge. So the SI units for charge are coulombs. The SI units for charge are what? Coulombs. Coulombs, which are represented by capital letter C. Then the SI units for current, we have already said they are amps. We are going to put a capital letter A there. And finally, we have time. So the time, remember time in physics. Time in physics, it is always in what? In seconds. So seconds is small letter S will do. Okay. So we want to answer our question now. So the question is saying calculate the charge in 1 minute. Calculate the charge in 1 minute. So we're going to say charge is equals to current. So we're going to use the total current that we answered in question D, which was 5. Then we're going to multiply it by the time. So the time from the question they are saying 1 minute. And here we have said that time should always be in seconds. So we are going to convert the 1 minute into seconds. So 1 minute is what? Is 60 seconds. 1 minute is 60 seconds. Then we're going to say charge is 5 multiplied by our 60. 5 multiplied by our 60 gives us 300. So our charge is 300. Then remember we said that charge as units. So our charge is going to be 300 coulombs. Our charge is going to be 300 coulombs. Okay, so we'd like to appreciate you for joining us and encourage you to follow our Facebook page, which is Data Nerds, and also subscribe to our YouTube channel, which is also Data Nerds. Thank you for joining us. This was Mr. Mwewa.